Here's page 15 in our matrix notes packet. We're talking about an augmented matrix today. We're also going to learn about how we can use inverse matrices to solve a system of equations. So filling in the blanks here, an augmented matrix is a method of writing a system of equations in matrix form, where we're adding an additional set of numbers onto the set of numbers we have in our matrix. So you can see that down here in this example. Write each equation in standard form. So this is our system of equations. They're in standard form because they have all the variables on the left and the constants on the right, and the variables are in alphabetical order. So each row of our matrix represents the coefficients from one equation. So coefficients are the numbers next to the variables. And then each column represents the coefficients from one variable. So in this example, we have x, y, and z. So for the first column will be the coefficients on x. The second column will be the coefficients on y, and the third column the coefficients on z. And then the constant for each equation, that's what the equation's equal to, is written last over here. And then sometimes we put a line in here that represents the equal sign. We don't have to write that line, but sometimes that is part of an augmented matrix. So let's look at this example here. We have our system of equations, x minus 2y plus 3z equals 7, and the first row has already been done for us. So there's no number next to the x. That means the coefficient is an invisible 1. So you can see the first number in our matrix is a 1. And then we have a negative 2y, so the next number is a negative 2. And then we have 3z, so the next number is a 3, and then 7 is the constant. So what will the numbers be for the next row of numbers, for the next equation? 2, yep. 1, good. 1 again, good. And 4, awesome. And then our last row of equations, remember how we want the first column to be x, the second column to be y, and the third column to be z. So we have a negative 3 next to the x. We have a 2 next to the y, but there is no z. What does that mean we're going to have to write for z? So we can't leave it empty. It's actually going to be 0. It would be 1 if there was a z like in the row above it with no number in front of it. But this time there's not even a z. And so we have a 0 for that term. And then over here our constant would be a negative 10. Okay, try the next system of equations and writing those out on your own. If you're watching this video, you could pause the video and try it, and then start the video again to see how you did. Okay, so let's check this together. So our first equation has a 4x, so I'm just writing down the 4, a 5y, so I'm just writing down the 5, z, so we just do a 1 for the z, and then a 24 for the constant. Right? Keep going like that, and I will just be writing these down, and you can see if your answer matches mine. So be trying it on your own, and then look up to check your answer. So here we have two examples of augmented matrices that we've taken systems of equations and written the numbers in a matrix form instead. Again. Okay, something we're going to see here in just a few minutes is another way of writing a system of equations as a matrix, or actually of several matrices, and we're going to be using this method more than the augmented matrix today. Augmented matrix is a good way to solve equations using a certain method that we're not really going to talk about much today. The only thing I'm going to mention at all is if you were to learn about and use this method, and this last page shows you how to interpret those solutions. Because what you would do is get your augmented matrix to have 1s and 0s in it like this, and then these would be the solutions over here. But there are sometimes when we get infinite solutions or no solution because things turn out like the examples on this page. But otherwise, I wouldn't really worry about that page. That's stuff that I teach my college algebra class. So it's in the packet, but it's not something we're going to spend any time on. Okay, coming back to where we were. So let's look at this last example here, and we're going to write it this other way as a matrix equation. And we'll talk more about matrix equations here in just a minute. So when we write this as a matrix equation, we're actually going to write it as three separate matrices. So we're going to have a coefficient matrix that goes with these numbers right here. So 4, 5, 1, 2, -4, 1, 5, -4, -5. Then we would have another matrix or a variable that represents a matrix. We could either have a single variable that represents our variables in our matrix, so we could just call it like x or something like that, right? And then that would be equal to the constant matrix 24, 0, 12. Okay, instead of just putting one number in here though for our variable matrix, we could write instead that x represents a matrix for each variable x, y, and z. So when I said or, that means I could have just written that matrix in there. Or I could just say this x represents the matrix where it's a 3x1 matrix with the variables x, y, and z. And that is another way of representing this system of equations. But this time, instead of an augmented matrix, which is what this is called, we're using a matrix equation. Okay, we're going to come to more details on this in the next video, the next page of